Hey everyone, this is Matt with Learn Everything About Design, and in today's video, part 2 of our 3-part series of 3D scanning to part design, we're going to be taking a look at the scan data, we're going to process it in RevoScan 5, and we're going to have a clean mesh output at the very end of it. So in this video, we're taking the scan data from part 1. So if you haven't captured any scan data and you need to know that process, make sure that you go back and watch the first video in the series. Remember that we are using the Revopoint Mini2 scanner for this series. We are an affiliate channel, so if you use the link in the description, it does help the channel out. There is also a code LEADREVO100 that'll get you $100 off the purchase of a Mini2. So without further ado, let's hop into RevoScan and let's take a look at this mesh data that we captured in the previous video. Now that we have all of the scan data captured, I like to bring it back to my desktop because it's a bit more powerful of a machine and it handles the processing a bit easier. Now, full disclosure, I did scan everything a second time. And the main reason for this is because the garage lights are fairly bright, and in order to film scanning an object, what oftentimes happens is the exposure is just not quite right. So doing it in a slightly darker room without those really bright ceiling lights allows me to capture the scan data a bit better. So I did the same 3 scans. I had one that was up higher, I had one that was down lower, and then the sort of original one that was somewhere in between. So what we're going to do is we're going to go through the process of cleaning these up and seeing if we need just one of the scans or if we need all 3 of them. Now, it's important to remember that processing mesh is mostly science, but also a little bit of an art form. And what that means is when you're scanning data with a Revopoint scanner or really any other scanner, you need to make sure that you understand what the options are doing and make some decisions based on your end goals. So at a first glance, the scan looks pretty good, but you'll notice that there is a lot going on in the corner here where the fillets are. There's stuff that's happening up here. And essentially what happens is when the scanner is scanning an object, and we'll kind of turn this around, these extra bits are where it can't quite understand what's happening with the light pattern that's being projected on the object, and it's bouncing back and it's causing this noise. And we see that inside of that fillet there, and we see it over in this corner. If we look at the second scan that was done a bit higher, it still has that as well, and the third scan as well here. So essentially what's happening is when those points are further away from the scanner, we're getting close to that end of our range. And because those exposure values are beginning to drop below sort of an ideal range, we end up getting a lot of extra noise. And this is why setting that exposure value initially is extremely important, making sure that it's in the right area. Now, the good news is we can process a lot of this out because we do have clean scan data from different angles. It means that we can get rid of some of that noise. So what we're going to do is we're going to begin by first using the fusion process. And basically what's happening is what we have if we zoom way in is a bunch of points. Now, these points are in space, and based on the number of frames that we've taken, the number of times that the turntable has moved around, there may be a case where some of these points are really close together. So it might be kind of hard to see, but there are 2 that are relatively close together here. There are 2 close together here, 2 here, and so on. Now, any of those points that are within 0.08 millimeters, because we're using the advanced setting, oftentimes you'll see that the lower end of the scale will be somewhere between 0.08 and 0.1. And those essentially means that anytime points are that close together, it'll merge them into a single point. So we're going to apply this, and this is the first step in the process of making sure that we're getting rid of or filtering out some of that noise. Now, that noise is not necessarily a bad thing if it's close to the surface of our part. Now, if these points are not just next to each other on the same surface, if they're too high or too low, it'll also begin pulling those together. Now you can see that this has instantly made the scan look a whole lot better. There's still a lot going on in here that we need to clean up, but that looks a world better. And if we zoom in, we can kind of see what's going on here. The points are a little bit more consistent. Some areas, like in this corner, you can kind of see the orientation of those points, but for the most part, that looks pretty good, especially when you're zoomed out. The next step in the process is for us to do what's called an isolation. Now, the isolation rate of 15% is the default, and we're going to start there. And essentially what this is going to do is it's going to look at the mean or the largest set of point clouds, and then it's going to begin to filter anything that's 15% or smaller relative to that big object size. And this selects them for us, and we hit apply and it'll delete them. Now, you will notice that it did not grab those little paper pieces that we put on there. What we can do is we can increase the isolation size. Let's try about 35%, detect, and based on, again, the overall number of points in the main body, it should pick up a lot of those on the outside, and we can hit apply and clear those away. You can also use manual options to just select and hit delete on the keyboard to get rid of that as well. So that's a pretty good result. I think everything looks pretty good here. We've got a little bit of noise on the corner, which we can clean up. And we've got some extra stuff going on the inside and a few spots where maybe we didn't get very good clean scan data. But overall, I'm really happy with this scan and probably don't need any of the other scans at all. But what I want to do is I want to clean this up a little bit. So I'm going to start by getting rid of that section there and just hitting delete. And then I'm going to go to my polygon tool. Now, when you're on a polygon tool, you can't use the left mouse button to rotate without holding down control. So you will just need to make sure you hold down control. There is also an option to do a plane cut. So this option right here, we've got invert selection. We've got the option to select all, and we've got the option to invert the selection, and this one allows us to see through. We can do a plane cut, but honestly, in this case, all we really need to do is rotate until the front edge, and I'll zoom in so we can see this, the front edge and the back edge align. And you can do that from far away and still see it. And then I'm going to come over to the left and just draw a straight line. It doesn't need to be perfect for what we're doing. RC cars don't generally have extremely high tolerances, and we'll just hit delete and rotate that around. Now we've got a nice clean edge to work with. There is a small point here that's kind of floating around in space. Again, we can manually select that, or we can go back and apply isolation again, and it'll find that for us. I'm going to go ahead and just select it because I'm here. It's just one point out in space. Hit delete, and now that looks pretty clean. I'm going to go back to my selection tool, and if we want to do any cleanup in the screw holes, we can. I'm probably going to leave them because oftentimes what happens when you begin coming in here and trying to cut these out, you end up making a little bit more of a mess. And what I mean by that is you get rid of some data that might help you figure out where this hole is. So if we just try to clean that up, you can see that's not really a circle, but it does a decent job. And you know what? I'm going to go ahead and do that on the other one. And let's go ahead and pull this down. Again, hold control and the left mouse button to rotate. I'm going to zoom way in because I don't want to overlap anything. So just going to try to draw a nice close to circle. And notice that I'm staying away from the edge. I'm only trying to get rid of the extra points on the inside. And these happen whenever we're scanning down into a hole, for example. You're going to get a little bit of noise. And the noise basically is when that light is trying to bounce back and it bounces around inside that hole. But that's actually a really good result. Now, that hole size is about 0.1 inches. So it's pretty small. It's a pretty small screw. So it's basically a passing hole for like a 2.5 millimeter screw. So to get that kind of result from scanning that, I'm actually pretty happy with that. While we're here, I'm going to go ahead, since I already cleaned up one, I'm going to go ahead and just clean up this other one a little bit more as well. And as I said, you don't really need to do this. We're going to be doing some processing in CAD, and we have a measurement for those holes, and I think we can get close enough to what we need there. The last thing that you would want to decide is if you want to do any cleanup on the inside here. Now, it's not going to have a perfect scan for the inside because obviously it can't get underneath those faces, but I am pretty impressed with how much it did capture, but I don't really need anything in here. So the biggest thing that we want to look at is there's a plug that gets pressed into this if you need to access the tension screw for the clutch, basically. That you basically pull out a little plug here and you can get to the back side of that. What we would want to figure out is how much of that we need. Now, whenever we're selecting from the inside of an object like this, I would caution you on doing this, but if you do, make sure you turn off the select through option. So that way, when we're dragging this around and we're trying to remove some of this, let's come back around. You want to make sure that what you have selected doesn't go through. And you can see here's the big problem. Now, if I just hit delete, which I'll do, I now have a hole in the side of it. So we need to use the undo to bring that back. But that's the biggest problem that you have when you're trying to clean that kind of thing up on the inside. So for the purposes of this, I'm going to leave it. It's not important to what we're doing. I really only need the outside. So I could cut it. And generally, what you would want to do if you needed to try to select that is we would rotate this object around like this, make sure select through is turned off, and grab everything. And when we do that, you'll notice that, for example, it does not select the inside. Then we can do something like invert selection and try to grab some of that. Not a perfect solution, but it is something that we can do. I'm going to go back to these tools here. Now, I really don't see any need to process any of the other scans. They're there if we need them. And as I mentioned, much easier to capture extra scan data than to have to go back and set everything up again and recapture it. Now, as I mentioned, I did scan this a second time, and really the main reason was because of the ceiling lights. Wanted to have a lower sort of ambient light amount to scan this. That's usually the best. You'll find that with the Mini 2, the Morocco, the Inspire, the Pop series, the Range, all of these are going to have a harder time scanning outside than they do inside. So whenever you can control the lighting in your scene, in your scenario, that's a better option. Now, we can take a look at doing overlap detection. Not really going to be big in this case. I don't really even see anything it's selected except for maybe a couple little points in here and one there. But basically what this is doing is if you ended up with a couple points that are overlapping, then you'd be able to basically find and filter those out. Usually you don't get much unless you've got a really noisy scan. This one's pretty clean. So the next thing that we could do is smoothing. Now, this is somewhere I would really caution you. Smoothing out the points can have a negative effect on your results, especially if you're trying to capture small details. And if you're using the Mini 2, that's something that you want to be aware of. So generally what I would say, and because we do have an undo and redo in here, it's easy for us to show, if you use a higher strength value and a lower times value, let's look in this sort of region here where the two shapes come together. Basically what's going to happen is it's going to move the points further and it's going to do it less time. Now it's going to be very minimal in here, but what you're going to end up noticing is this valley will change ever so slightly. So we're going to undo that. Generally, if you've got a really good scan, you would want the strength number to be lower, somewhere around 5, and then you can maybe increase the number of times. And what that's going to do is every time it's trying to smooth out hard edges, and maybe another place that we could look at this is maybe up here. Every time it goes through and tries to smooth out hard edges, it's going to move them less. So the strength value is going to determine how far those points can move, and the number of times is going to be the iterations it goes through. So if we apply a smaller strength and a higher number of times, this will gradually allow us to smooth these out. You will notice that there are going to be some points where we've got like a point floating here. So after you go through this process, you can always go back and rerun things like isolation detection. I'm going to kick that number back down, detect, and see if it finds any points. There may be one or two. You can see a couple here, and we'll just apply those. So again, word of caution, be careful when you're trying to use things like smoothing. Be very, very careful with the shape that you're working with. If it's got hard edges, pay close attention to that. Now, you will notice that there is a small bump down here. I'm not really concerned about that. Could have been a little bit of extra buildup for scan spray. Could have been bad scan. Could have been part of the smoothing process. We really don't know. But just keep in mind when you see stuff like that, generally if you're reverse engineering something, you would omit that, meaning that you would just assume it's an anomaly and sort of go past it. Now, simplify, I don't generally do a simplification process. And part of the reason is I don't really like the way that it decimates the points. And what we're going to do is we're going to take a look. So right now we've got a pretty dense clustering of points. And we've got two options. We've got a uniform and we've got a geometric. And the geometric is going to put more points in tighter transitions, so it's generally going to be a better option. But essentially what you're doing is you're saying, I want to take the number of points that I have here, and I want to go down to 40% of that. So if you look over here, we've got 923,000 points, so just shy of 1 million points. And if we apply this, what you're going to start to notice is some areas, and you can see now we're at roughly 550,000. Some areas will have really sparse points like this, and other areas will be a bit more dense. And you'll start to notice this, what almost looks like marbleization. And part of that is because of the points, the way that they're captured from different angles of the scanner. So if you were to do just a single frame scan and you weren't dealing with hundreds of frames, you wouldn't really notice this as much. But I generally try to avoid using a simplification unless you've just got a extremely large, unmanageable scan. So I think that's pretty good to go to the next step, which is turning this into a mesh. So we're going to select the mesh process. We're going to use the highest grid size or quality size that we have, which is the smallest grid number. In this case, that's 0.09 millimeters. So essentially what this is doing, when we think about turning these points into triangles, so essentially connecting all of these points into little triangles, it's going to use a grid size of 0.09 millimeters. If we were to go to something larger, like let's say 0.5 millimeter, we're going to lose a lot of detail, especially in areas that are smaller than 0.5 millimeter. So generally, depending on which scanner you're using and your settings, you'll see 6 or 7 will be the max value, and you want to make sure you look at that grid size. I'm not going to turn on hole filling because it's going to try to fill in the screw holes and things like that, but we're going to say apply. Going to let it go through the meshing process. And after that, we can take the mesh and export it to our CAD program to do further mesh processing if we wish, or we can continue to use some tools like isolation, filling holes, smoothing, and do a little bit more work on it directly in RevoScan. So here's our result. It looks pretty good. And again, if we zoom in, you can't see the points anymore because now this is turned into a mesh. We do have some display options up here. So right now we can take a look at the way that the mesh model is displayed. We can show it as a wireframe. And if we zoom in, you can see all the little triangles that were created. Now these are really small, remember 0.09 millimeters. So when you zoom out, you can't really tell that it's a mesh. It just looks like it's a very bright object. For the most part, you want to turn off the wireframe and just look at sort of a smooth or faceted display. We do have some other options. We can take a look at model properties and we can change the color. So if you're having a hard time seeing things like curvature, you may want to change the color. You can also make it matte or shiny, and you can get a good idea. A lot of times shiny or matte will give you a good idea as to the quality of the mesh. So if we apply that, we get a little better idea of things like high spots and low spots. So overall, it looks really good. I'm happy with the quality of the scan. This is a small part. Remember, these holes are under 3 millimeters to give you just a good size reference. They're really small holes. So I'm happy with the results that we have so far, but we can do a little bit more. First, we're going to take a look at isolation. Just like we did with the points, we're going to check the isolation, see if it found anything. Doesn't really look like it. Maybe some fragments along the edge. So we'll hit apply, allow it to clear those out. Now that we're at the mesh stage, if we want to remove anything in here, we can. Because we're not going directly to 3D print, we don't have to worry as much about doing some processing on it like that. But if you were trying to take this to 3D print directly, that would be something you would want to do. Make sure you clean all those edges up. Not going to fill holes, but the way that process works is you would detect the holes. You could use a plane or you could use curved method. So if you're trying to fill a hole in the side of a shape, you would want to use a curved method. But we want to look at smoothing. Now, once again, strength and times, and we're going to do this in 2 instances. Let me see if I can get a better shot here. Really what we want to look is in some of these sharper corners. I'm going to use a higher strength value and a lower times and apply and see if we can tell the difference. So if we go back and forth, one of the main areas I want you to look at is look at the light reflections and shadows that are happening on these edges. So when we undo and when we redo, we want to make sure that we're not losing any of those edge details. So redo and undo, and it actually doesn't look too bad. It looks like we've kept most of those details, and just rotate it around, redo and undo, and just see what it looks like. And because we have undo and redo, and even the option to remove all the edits that we've made, including the mesh, including from the point clouds and starting from scratch again, we have the option to go back and forth and test these settings out. Now, if we increase the number of times and decrease the strength, this is going to allow it to go through multiple iterations, moving the triangles a little bit at a time. And basically what it's looking for is triangles with high edge angles, and it's trying to minimize those. So again, if we look in certain areas here, we're going to undo and redo. And basically, if you look at lines that you can see on the scan, it's probably going to be kind of hard to do here, but you can go back and forth and kind of tell what's happening. Now we're going to do one final test. We're going to increase the strength and the times and allow it to go through. So basically it's going to be as aggressive as it can be to smooth out the mesh. And it's going to do it over, in this case, 17 times. And really the last thing that you want to look for here is to make sure you're not losing hard edge details. So undo and redo, and it doesn't look too bad. Most of the deformation that you're going to see is most likely going to come from simplifying and smoothing at the point cloud level rather than doing it at the mesh level. The mesh level, because we've got so many triangles, and again, if we turn the wireframe on, it's got so many of these small triangles. In order to make a sizable difference, it would have to move these triangles quite a bit. So because we have such a dense mesh on this body, it's not able to make drastic changes overall, which is good for us. That means that we can increase the strength, increase the times, and continually apply it, see if it gets better, and see if we're ready to take it to the next step, which would be a CAD program, or if you want to further process it in something like MeshLab, which is a free software, you can do that. I'm going to do one last check, rotate it around, make sure everything looks okay. The main things that I need are going to be details like this flat section here. I'm going to have to build a plane because we're going to loft from this sort of oval or slot shape down to the base here. And I would need to get a reference off the top of this. I would need to know the ID here. These little cutouts are really not needed for what we need. We just need to have a circle or a hole there. Pretty happy with that. So I'm going to go back to my display and put it back to diffuse. And that looks really good as well. So once you're happy, it is a good idea to make sure that you save your project. Remember, you can go back and remove those edits at any point in time. But at this point, I think we're ready to export this. So I'm going to go ahead and export this as a mesh model. Make sure that we have the right location and also that we have the right file type. And we can save it as a PLY, an OBJ, or an STL. Now, if we're bringing this into Autodesk Fusion, we want to use an OBJ. It's going to be our best option. And I'm going to say RC truck, and this is our gearbox cover. Scan. Now, before we get out of Revo Scan, we're essentially done with the mesh portion of it. This is now the time where we bring it into Fusion and we would make a CAD model of whatever we need. But before we do that, I do want to go ahead and hop back into the other mesh files. And I'm going to go through the process of doing the fusion for each of these. And the main reason for this is I want to talk about a couple of other steps in the process. And oftentimes when we're creating scans, at the time we're scanning, we have the ability to pause and undo frames. The Mini2 also has the option to process out some of those shaky frames. We didn't run into that here because we were using it on a tripod and we had a turntable. So essentially we had the most isolated or controlled system possible. When you're using it in handheld mode, we are not perfect as humans. We tend to move it around a little unpredictably. So if you are using in handheld mode, you might find yourself needing to filter some stuff out. So what we're going to do is we're going to talk about that. I'm going to go through isolation using all the same settings, allowing it to detect and remove. And we're not going to do a full process here, but I do want to select everything here. So I'm going to select the main body. And then I'm going to invert the selection. So again, we select invert and then just hit delete, and that'll get rid of those for us pretty easily. And that looks pretty good. Now, this scan, just like the first one, looked pretty good. However, you can see that it's missing information on this side. Now, part of that could be from selecting and removing data. Now, this happens all the time. When you're working in RevoScan or really anything, you have to pay close attention to your options like select through. I had select through turned off from the last mesh that we were working on. So what I didn't notice is that I selected all these faces, or I didn't select all these faces that were hidden. So if I undo, you can see it brings all those back. What I want to do is make sure that I've got select through turned on, and then I can make sure before I select delete that I rotate this around and make sure everything's selected. And then I can invert my selection. So again, click invert and now hit delete. So that's one thing you want to be very careful with. And I do it all the time, especially when I'm selecting things on the inside and I have select through turned off. I accidentally select a small piece somewhere else and delete it without thinking, and I don't realize it till later. So pay close attention whenever you're making selections inside, or if you're using sort of a box selection over the whole thing. Just pay close attention, rotate it around. The other thing I want to mention here is that we have the option to do what's called keyframe edits. Now, keyframe edits can be very painful because essentially what we're looking at is each frame that the scanner saw. So if I play through this, this is basically everything that the scanner saw throughout the entire scan. You can see that now it's rotating around. This was on the turntable, and it's looking at each frame. Now, the reason that this is important is because sometimes we get bad frames, and we may need to go in and find those. So you can shift select several frames, groups of frames, or you can shift select the entire thing, and that'll help you find and isolate individual frames that you may want to remove. Keep in mind that if you do this after you've done any processing, so for example, isolation and overlap detection, then it's likely going to remove those edits as well. So just be careful that you think about those order of operations. So if you are going to do any keyframe edits, do them first before you ever process anything. Now I'm going to come in and clean up the second one as well using the same settings. There is a one-click method that you can use. I personally don't use the one-click option, but if you're bringing in standard scans, something like a small clay figurine, or you're working with something that is pretty consistent over and over again, you might find that the one-click processing helps because it goes through all of the standard settings for the point cloud edits for things like fusion and isolation detection, and it also goes through the mesh settings as well. So if you really want to skip all of the nuances of these individual points, then you can go through that process of using the one-click edit, and then it'll make all these decisions for you with these default settings. But again, for me, I like to have a little bit more control over it, so I always go in and I do this manually. Now, the main reason that I want to go through this process, and let's go ahead and invert that selection, but the main reason I want to do this is I also want to show you how we can go through and merge a couple of different point clouds or mesh files. Now, we don't really need to because we got everything captured in one scan, but if you happen to have multiple scans, so for example, a top and a bottom of an object, then you would want to come in, select the scans that you want to align, and in this case, because we used feature tracking, we're going to allow it to automatically pick the points where it thinks things should go together. Now, there are options to do this with markers, and the marker alignment is slightly different. So, for example, if you click marker alignment, you may think that this is actually the scan markers, but really what this is you picking points on two different versions of the point cloud or mesh file. So, for example, I may pick a point in the middle of this face by left-clicking. Then I may need to look at another point. Maybe I'll come down here in this area because that's pretty unique. I'll try to find where that little recess is too. And then I need to at least pick a third point. And then we want it to be somewhere unique. So maybe on there. And I'll try to get to the same point on this one or pretty close to it. And with those 3 points, you can see that the alignment is pretty close. So if you have to do this manually, if the feature tracking isn't working, then the marker option is a good way that you can manually pick points if the alignment's not working very well. But feature tracking does a pretty good job. So what you would want to do is generate the model. And what happens with this process is it's going to take both of those point clouds. It'll create a third merged point cloud. So you're not going to be manipulating, or you're not going to be ruining any of the original data. But after you do this process, you want to go back to isolation detection and overlap detection. You'll pick the merged object. We're going to run through the process of doing isolation detection, already fused together because it's essentially all the points that we've already captured. And the big thing that we want to look at is overlap detection. Now, because we took two nearly identical scans and we essentially just put them on top of each other, overlap detection is going to help you make sure that you clean a lot of those bad edges up. And then also I'm going to come through, rotate this around until I start to see the other side. And then I'm going to do a cut through here. I'm going to take a little bit more. We're not using this one here, so I'm just going to remove a bit more of it. But that allows me to clean up that bottom edge. Having a sort of a jagged bottom edge, not something that we really want to do when we're talking about converting it to a mesh. It's just going to get kind of messy down there, so we want to make sure we clean that up as best as possible. Whenever we have an object that's sitting on a flat plane, that bottom edge can be a little bit ragged. It's something that you need to keep in mind. Whenever you can actually scan around the bottom edge, that is helpful, especially if you do need to scan the inside. But for what we're doing, it's perfectly fine. So those are the main tips that I wanted to share, talking about the point cloud edit and the mesh edit, and actually exporting the mesh that we have. Because we did it in a single scan, that is the most ideal situation. But if you do have to use multiple scans, merging them together is actually not that bad. Using the automatic options for generating it based on features does a pretty good job. Not always perfect, but it does a pretty good job. If you do have multiple scans, for example, if you've got sort of an area where the scan is a bit noisy, make sure you cut away and clean up those edges before you try to merge them together, because that'll be much harder to remove once you put two point clouds together. But now that we've got this part of the process down, I am going to do one last save. Again, remember, we can always undo any of the things that we did. We can go back to basically the starting point in here by just going in and deleting all the edits. Not something we're going to do, but just a nice feature that allows us to go back. But now that we're done with the editing portion of the point clouds and the mesh, we can move into CAD and begin creating our model so that we can 3D print a new cover. All right, so now we're at the end of part 2 of our 3-part series. We went through and processed all of that raw point cloud data, turned it into a clean mesh that we can now move into Autodesk Fusion. Now, remember I mentioned at the end of the first video that if you have bad scan data coming in, there's really not going to be any fixing that going forward. So if you had any problems in the second part of this process in cleaning up that mesh data, it's going to be a good idea to go back to the first step and rescan. Now, there's no problem in that, and you'll find that as you're getting started in 3D scanning, whether it's with any of the scanners from Revopoint or anybody else, you're likely going to have to do that over and over again until you're confident in your ability to capture that scan data. We always want to capture more than we need because it's much easier to trash that later than it is to think that you need to go back and capture more. So take the time to clean, prep, set up everything, and capture as much scan data as you think you need, then capture a little bit more and move into processing those point clouds. In the processing of the point clouds, make sure that you take your time, but remember that in RevoScan 5, we can undo or delete any of those edits and start from scratch. So if you had any problems in this step of the process or anything else, please leave a comment below. Remember, we are an affiliate channel, so if you are going to purchase a Mini 2, use our affiliate link in the code LEADREVO100 to get $100 off at your time of purchase. So as always, thanks for watching, and we'll see you in the next one.